In this class, we will discuss about the photoconductive transistors, ionic transistors, Hall effect transistor, and finally discuss about the digital displacement transistors. Okay. Now we go to photoconductive transistors. Normally, photoelectric transistors means we give the input of the part is the light source to the semiconductor part. Okay, then we will get the output of electrical form. Okay, that is input is light beam of the input, output is electrical form of the quantity or electrical part of the output. So in the transistor, what is the role of the transistor here? It is converted from light quantity to electrical quantity. So in the instrumentation part of the transistor, measure the output in the form of current or voltage. Here in the photoconductor transistors, we give the input of the light to the semiconductor material. That part is processing, then deliver to the product of the electrical part. That is the electrical result of current. Okay. Here the current is saved by energy. So in the photoconductor transistors, by using ammeter. Okay, the ammeter is used for saving the energy from the light of the beam to the energy. Okay, so a voltage is impressed on the semiconductor material in this diagram. When the light strikes the semiconductor material, there is a decrease in the resistance. Okay, thereby producing or increasing in the current indicated by the meter. That meter by using the ammeter. Since photoconductive transistors enjoy the wide range of the applications and are useful for measurement of the radiation at all wavelength. So the wavelength is depends upon the using the instrumentation of transistors of materials. In the photoconductive must be noted, however, that extreme experimental difficulty may be encountered when operating with long wavelength radiation. The long wavelength radiation calculated by the responsivity of RV. Here RV is detector. The detector is defined as RMS output voltage divided by RMS power incident upon the detector. That meaning is rotation of the current saved by the ammeter by using the energy level. So that and the detector detect by the RMS output voltage and RMS power. Then to find out the noise equivalent power, that is NEP. Why we have using the noise equivalent power means, suppose we have saved the energy by using the ammeter. Any noise occur to that instrumentation means that part is defined by NEP. That noise equivalent power is defined as the minimum radiation input that will produce a signal to noise ratio of the unit. Finally, we conclude the directivity of D is defined as RV divided by RMS noise voltage output of the cell. Here RV is the detector. How to calculate the detector? RMS output of the instrument divided by RMS power. Okay. Then the directivity is reciprocal of noise equivalent power, so that a normalized directivity of D is defined as A into delta F power 1 by 2 into D. Here D is the directivity. Here A is the area of the detector and delta is the noise equivalent bandwidth. So the unit of the D star are usually centimeter into hertz power 1 by 2 or watt. That is the current voltage. Okay, sorry, current unit. And the term is used in decreasing the performance of the detector, so that in the particular surface area and bandwidth will not affect by the instrumentation. Okay. The next part is ionization transistors. Here in the ionization transistors, let us consider this diagram. In this diagram, we have using the ORF generator. The ORF generator generating the current from the light of input by using the gas-filled tube. That is for displacement of some coils. Okay, that coil is called plate. So in the both the side of the gas-filled tube contain the plate. Okay, the plate displacement denoted by X. In the gas-filled tube, rod is called that is noted 1 and 2. In between the 1 and 2, we have saved the energy in the ionization transistors. So ORF transistor generator is a generate the energy of the product. Here the tube contains the gas at low pressure, while the ORF generator impresses the field on this gas. As a result of the RF field, a glow discharge is created in the gas and two electrode, okay, that is called electrodes 1 and 2, detect the potential difference in the gas plasma. The potential difference is the displacement on the electrode spacing and the capacitive coupling between the RF plate and the gas. When the tube is located at the central position between the plate, the potential on the electrode as the same. Same means in between the two plates. But when the tube is displayed from this central position, a TC potential difference will be created. So that the ionization transistors is the useful device for measuring the displacement in the instrumentation. Best way, we have measured the displacement by using the ionization transistors. Okay. The next part is the Hall effect transistors. In the Hall effect transistors, consider the photoelectric transistor. Additionally, we have put one thickness of the plate on that materials. Okay, so a semiconductor plate of the thickness T is connected as in this diagram. That is one external current I passes through the material. Okay. When a magnetic field is impressed on the plate in a direction perpendicular to the surface of the plate, that plate is the perpendicular of the surface of the plate means that level of the thickness passing the current from the input to output, or one of the energy form to another energy form. Okay. And therefore, the potential of energy effect generated by Hall voltage. Okay, the potential energy is called Hall voltage. The Hall voltage is calculated by KH into IB divided by T. Here, H is the some quantity of particular material part. Okay, here I is the ampere. That meaning is current. So V is the gases and T is the centimeters. Here V is the gases means in the current is passing one thickness semiconductor plate in that plate have some quantity of the values. That value is indicated by capital B. Okay, T is the centimeter. That is the thickness of the plate. Finally, the proportionality of the constant is called the Hall coefficient and has the unit of the volt centimeter per ampere gases. That meaning is the Hall effect unit is a centimeter per ampere gases. And that meaning is current involved, then surface is involved, then thickness is involved. Okay, three component involved to the product of the current in this transistors. Next, in this table, given some Hall coefficient for different materials. Here, 9 material given, and their field strength G is given, then temperature is given, then finally the last column given for KH, that is the Hall effect constant for the particular material part. Here A is the arsenic, C is the carbon, P is the bismuth, C is the copper, F is the fluoronic, G is the germanium, Si is the silicon, Sn is sulfur, Te is tellurium. Okay, these are the material mostly used in Hall effect transistors. Okay, why this type of material we have used in the Hall effect means that material thickness is a leverage. Okay. The last part is the digital displacement transistors. What is meaning of digital displacement transistor means we have using some plate. That plate thickness we have mentioned by X or Y. That part is displaced to the transistors. Finally, that output of the any form converted to the digital of the product. That meaning is giving the input is the analog means the analog of the input quantity finally deliver the output of digital form. Okay, here in this transistors can be used for two types. First one is the angular, second one is the linear measurement of the digital displacement transistors. Okay, the first one is the angular displacement. In the angular displacement, we have we have using the input of the light source. So the photoelectrics is converted from the light source to the current. Okay, current is the output of the process of transistors. So light of the source by using the cut out method, the cut out method used by the safety of the some indication, that the indication move to the photo detective. And the photo detective have some semiconductor material part. Okay, that semiconductor material part is converted to some type of the production. Uh, uh, that production by using the amplifier in the angular displacement. Okay, finally that output of the electron indicated by the counter. What is meaning of the counter? Counter is convert from a number of input to one number of output. Okay, here the wheel rotate line from the source is iteratively transmitted and stopped, thereby submitting the digital signal to the photo detector. The signal is then amplified and sent to the counter. The number of the count is proportional to angular displacement. The frequency of the signal is proportional to the angular velocity. So the sensitivity of the device may be improved by increasing the number of the cutouts. So in the rotation of the cutouts, improve the quantity of product or result in the displacement transistors. The second part is the linear displacement. In this diagram indicated by reflecting the strips, the light sequences, then the light sequences is reflected to photo detector. The reflection is moved to the next steps. Okay, to convert the result of the current. Here a linear transistors which operate on the reflection principle by using photoelector. Okay, the small reflecting strips are installed on the motion device. Light from the source is then alternatively reflected and observed with linear motion, thereby presenting the digital signal to the photo detector. A readout is the same as with the angular instrument in the linear displacement, and calibration with the known displacement stand must be performed in the linear displacement. That's all.